proprietor of Graceland Academy. I'm here to present you with simple machine in physics, in which we are going to concentrate on a Pully system. A simple machine, by definition, it is simply the device that makes the work easier. I mean, the device that makes the work easier. There are different types of simple machines, of course, one of which is the Pully system. I have drawn the Pully system here to the best of my abilities. There is also an inclined plane. It is also a simple machine. There is also levers as well as gears. Now, we cannot exhaust everything at once. So because of that, or because of time, our focus remains on the Pully system which I've drawn on the board. I will take you back through the definition of a simple machine, because definitely you can't understand, even as the story unfolds, as long as you don't understand what a simple machine is. Maybe let me try to be practical on this one. Assuming that you've got 500 newtons of load that has to be lifted by you, and you cannot afford because it's too much for you, and you get a wheelbarrow, and the Lord will put the load on the wheelbarrow. Definitely, you'll be able to push the wheelbarrow through a certain distance, meaning the work is much easier. Why? Because you have involved the wheelbarrow. The whole lot of this explanation is centered just on the definition of a simple machine. So a simple machine is a device that makes the work easier. A Pully system here is a simple machine. What we have on the board is the drawing of the Pully system. In every simple machine, the effort is required so that you can overcome the force that comes with the load. The effort in this type of the simple machine, supposed to be applied there, and this is the load. The force overcome. The effort is the force you are trying to apply to overcome the force here. Now, this Pully system comes with a good number of problems which you're supposed to know how to calculate as per syllabus. For example, the velocity ratio. In every simple machine, you need to understand how the velocity ratio is calculated. You need to understand what the velocity ratio is all about. Meaning every simple machine has the velocity ratio. The Pully system has got the velocity ratio. The inclined plane has got the velocity ratio. Because the object is moved. The load is moved due to the effort you have employed. So, if we look at the velocity ratio by definition, velocity ratio, it is simply the distance moved by effort, the ratio of the distance moved by effort to the distance moved by load. That is the velocity ratio by definition. But how do we calculate the velocity ratio in a Pully system like this one? To calculate the velocity ratio in a Pully system, there is no need to involve the formula. It is the matter of counting how many wheels we have in this kind, in the Pully system. So obviously, we've got about 4 of them, meaning the velocity ratio of the Pully system is 4. Note that the way we calculate the velocity ratio in the Pully system, that is not how we calculate the velocity ratio in the inclined plane. That is not how we calculate the velocity what? Simple machine. But for the pulley system, this is how you calculate the velocity ratio. I'll definitely take you through the definition of the velocity ratio. The velocity ratio is the ratio of the distance moved by effort to that of the load. Are we together? Now, getting into calculation of the velocity ratio. To calculate the velocity ratio, we are done here. For this one, this is how it's supposed to be. The velocity ratio is 4. How did we get to 4? We have counted the number of wheels, which the pulley system is made up of. Okay? So the mechanical advantage, we proceed. For the velocity ratio, it's a done deal. Mechanical advantage. Mechanical advantage. To calculate the mechanical advantage, the formula that will help us to calculate the mechanical advantage is this one. Load over what? Over effort. This formula is the one we're supposed to use to calculate the mechanical advantage. So we're supposed to have the load as the formula even the effort. If we do not have the load that's the effort, we cannot manage to calculate the mechanical advantage. Mechanical advantage is calculated in the same way. Being it is an inclined plane, we calculate mechanical advantage in the same way with the pulley system. It is only the velocity ratio which is different where we calculate, depending on the type of the simple machine you've been subjected to. So we are looking at the mechanical advantage. Let's make assumptions here. Assuming that the load is actually 200 newtons. The effort usually, as long as you have used a simple machine, the effort is likely to be less than the load itself. So these are just assumptions. We have this as your effort, the force applied. And the force you are trying to overcome is 200 newtons. So to calculate the mechanical advantage, you'll say the mechanical advantage is equal to, the load in this case is 200 newtons. What about the effort? It's 100 newtons. So the mechanical advantage is equal to 2. This is your mechanical advantage. We have calculated the mechanical advantage. Now, what is this mechanical advantage by definition? Because at times they will want you to define what mechanical advantage is. So you have to know what mechanical advantage is by definition. Mechanical advantage is simply the ratio of load to that of effort. That's why if you look at the answer, we did not even put the units because it is the ratio of load to that of effort. Even when it comes to the velocity ratio, it is the ratio, that's why we did not put the units. We are not going to put the units because it is a ratio. Therefore, this is how you calculate the mechanical advantage. This is how you calculate the mechanical advantage. Okay? So let's do away with this. That's how you calculate the mechanical advantage. Okay. Now, the last item there, it is actually the efficiency. The efficiency is the last item. So these are the three problems that comes with any simple machine. So in any simple machine, you need to understand how to calculate the velocity ratio, you need to understand how to calculate the mechanical advantage, you need to understand how to calculate the efficiency. Now to calculate the efficiency, okay, this formula here, we can use it to calculate the efficiency, which is mechanical advantage over what? Velocity ratio times what? Times 100. This is the formula for the efficiency. Okay? So, let's substitute the formula. Efficiency is equal to mechanical advantage. I think we had calculated mechanical advantage, it was 2. The velocity ratio, it was 4 times 100. Okay? So, efficiency is equal to 4 in there 1, 4 in there 25. This times that is giving us what? 50%. Therefore, this is the efficiency. The efficiency of a simple machine can never be 100. The efficiency of a simple machine will always be less than 100. Why? Because there is loss of energy to overcome friction. As you overcome friction, there is that loss of energy, that which compromises the efficiency of any simple machine. Okay? So this is all you need to know. So next time, maybe we'll go through other simple machines as well. Because I might not know which simple machine they are going to subject you to. Maybe they may not bring this one, the pulley system. they might consider bringing what's in print pen or level. So you need to have the information, full information about all simple machines. But what emphasis I'm trying to make is that they will definitely be asking about the Veloce ratio. If they don't ask you to define the Veloce ratio, they will ask you to calculate the Veloce ratio in any simple machine. If they don't ask you to calculate the mechanical advantage, they will ask you to define what mechanical advantage is, or perhaps the efficiency which we are just from calculating. But as long as you've got the formula, if the formula is actually the key, if you do not have the formula, you'll be stuck. Okay? Okay, so this is what you need to know about this. They can manipulate the question, they can twist it, but as long as you've got the information, then definitely you'll be able to solve that particular problem. Yeah?